Welcome back, everyone. Ready for another deep dive. Today, we're tackling a question that's, well, let's just say it's out of this world. Did life on Earth actually begin on Mars?
Wow, yeah, that's a big one.
It is. And to help us explore this mind-boggling possibility, we're going to be diving into a YouTube video from the channel Yuri,
Right.
titled Yu Wu Win Uri. We're going to be examining fascinating scientific discoveries, Martian meteorites, and the intriguing connection between the red planet and the origins of life on Earth.
That sounds like a wild ride.
It does, doesn't it?
Yeah.
So before we jump into all the evidence, let's set the stage. Most people know that Mars is our planetary neighbor, but what makes it a possible contender for the origin of life?
Well, a lot of things, actually. Mars is one of four rocky planets in our solar system, and, it shares some key similarities with Earth. It has seasons, polar ice caps, and a day length that's pretty close to ours. And most importantly, it sits within what we call the habitable zone of our solar system.
The habitable zone. So remind me, what exactly is that?
Right. So the habitable zone is that, Goldilocks region around a star where conditions are just right, not too hot, not too cold, for liquid water to exist.
Okay, so Mars might not be a tropical paradise, but maybe it's not as inhospitable as we once thought.
Right, exactly.
Okay, but similarities aside, is there any actual evidence, like concrete evidence, suggesting that life might have existed on Mars at some point?
Well, that's where the Curiosity rover comes in. Landed on Mars back in 2012, and it's been sending back amazing data ever since. And I'd say one of the most significant findings from Curiosity was the detection of these key elements that are, absolutely essential for life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. The basic building blocks for, well, everything we know as living.
Wow, so like all the ingredients for life were actually present on Mars?
Pretty much. But there's more. Curiosity also found high levels of boron.
Boron, why is boron so significant?
Well, boron plays this crucial role in stabilizing RNA. And, RNA is like a cousin to DNA, and it's considered by many scientists to be maybe a precursor to life.
I see.
And the thing is, without boron, RNA would be unstable in water, and it couldn't do the things it needs to do. So finding boron on Mars, it really strengthens that idea that, well, the chemical reactions needed for RNA to form and, potentially life itself could have actually happened there.
Okay, so we've got the ingredients for life, but did conditions on Mars ever actually support, life taking hold? Like, was it ever a place where life could actually thrive?
That's the million-dollar question. And to answer that, we kind of have to go back in time, way
Yeah.
back about 4 billion years, to a pretty dramatic event in Martian history, the massive impact that created the Borealis Basin. This is the largest impact basin in our entire solar system.
Whoa, okay. That sounds intense.
It was. Imagine a giant asteroid, or maybe even a comet, just smashing into Mars. I mean, with so much force that it carved out this crater covering almost half the planet.
That's insane. How would something like that, how would it change the planet?
Well, it would change everything. You see, before this impact, a lot of scientists think that Mars might have had a thicker atmosphere, maybe even oceans of liquid water. But that impact, well, it could have just blasted away a lot of that atmosphere and water,
Hmm.
essentially transforming Mars from a potentially life-supporting world into the, colder, drier place we see today.
It almost makes you think like Mars had a chance at life, but then bam, it was all gone in an instant. But since we're exploring this idea that life on Earth might have started on Mars, could that impact, that catastrophic impact, could it have accidentally helped seed life on our planet?
Now, this is a fascinating thought, isn't it? It's like a cosmic irony.
Hmm.
And yeah, the idea is called panspermia.
Panspermia.
Yeah, it's the idea that life can be spread throughout the universe, hitching a ride on asteroids and comets and other space debris. So maybe, just maybe, a piece of Mars carrying those early life forms was ejected into space during that impact, and it eventually found its way to Earth.
Like a cosmic game of billiards, but with life as the prize.
Exactly.
And you mentioned that impact happened about 4 billion years ago, which is, roughly the same time as the estimated origin of life on Earth. That's a pretty big coincidence, wouldn't you say?
It is, and it makes you wonder, doesn't it?
But how do we know for sure that Martian rocks can even reach Earth? Like, is there any evidence of that?
There is. We actually have we have a pretty convincing piece of evidence. A meteorite that was found in Antarctica back in 1984. It's called ALH88401.
ALH84001, catchy name.
Right. So scientists were able to confirm that this meteorite was from Mars by analyzing these tiny gas bubbles trapped inside of it. And guess what? Those bubbles matched perfectly with the atmospheric data that was collected by the Viking probes. Those probes that landed on Mars back in the 70s.
So we have an actual piece of Mars right here on Earth. That's pretty cool, but what's so special about this particular meteorite?
Well, in 1996, a group of NASA scientists announced that they had found evidence of, well, what looked like fossilized bacteria inside ALH84001. They were pointing to these intriguing features within the meteorite, including these tiny worm-shaped structures that they could see under a really powerful electron microscope.
Wow, tiny worm-shaped structures.
Yeah, and they also found these things called polycyclic aromatic hydrocarbons, or PAH, which are often associated with, the decomposition of organic matter.
Okay, so they found what looked like tiny fossils and chemicals linked to life. Is that it? Is this definitive proof that life existed on Mars?
Well, it's not that simple,
And of
unfortunately.
course not.
There's been a ton of debate surrounding those ALH84001 findings, and some scientists argue that the features that were observed in the meteorite could also be explained by non-biological processes, and the lack of clear proof of liquid water on Mars, back when ALH84001 formed. Well, that just adds another layer of complexity to the whole thing.
Right. It's like a giant puzzle where we have some of the pieces, but not all of them.
That's a great way to put it.
But even if this ALH 84001 meteorite doesn't offer, like rock solid proof of life on Mars, the fact that a piece of Mars actually landed on Earth, well, it opens up some pretty incredible possibilities, don't you think?
Absolutely. It
Yep.
really doesn't. Beyond the whole ALH84001 debate, we've actually been seeing more and more evidence from a lot of different missions that suggests that Mars did have liquid water, in its past. And there's even the possibility that it might still have flowing water today.
Hold on, wait. Flowing water on Mars, like right now.
Yeah, you heard that right. Back in 2015, NASA announced this groundbreaking discovery. They confirmed that there is liquid water flowing on Mars. It appears seasonally, so it creates these dark streaks on Martian slopes that seem to, expand and then recede as the temperatures change.
Flowing water on Mars. I mean, come on, that's just mind-blowing. But if Mars was once this, wetter, warmer place, what happened? What caused it to lose all that water in its atmosphere? And, could the same thing happen to Earth?
That's a great question. And it's one that's keeping a lot of planetary scientists up at night. But I think we need to save that discussion for part 2 of this deep dive. Before we go down that rabbit hole of worrying about Earth losing its water, like we were just talking about with Mars, it brings up another interesting point, another kind of key player in this whole story, Earth's moon.
Oh, right. Yeah, the moon. But what does our moon have to do with, the possibility of life on Mars?
Well, it all comes down to stability. You see, Earth's moon, it plays this huge role in stabilizing our planet's axis and tides. And this stability it's essential for maintaining a stable climate, which then allows life to evolve and to thrive over billions of years.
So you're saying that even if early Mars did have life, it might not have been able to, I don't know, really evolve beyond like simple forms without a moon like ours to kind of keep things in check.
That's one theory. It's all about that gravitational influence. The moon, it acts like this giant stabilizer, keeping Earth's axial tilt relatively constant. And that tilt, well, that's what gives us our seasons. And without it, our climate would be, well, it would be a lot more chaotic, that's for sure.
Wow. So no more cozy autumn days or like crisp winter snow. That would be a bummer. But I guess, more importantly, what you're saying is that having those predictable seasons is actually super important for the development of life as we know it.
Exactly. Without that stabilizing influence, Earth's wobble, the way it spins on its axis, would be much more, I guess you could say, pronounced. And that would lead to these crazy swings in climate. And I'm talking about swings happening over tens of thousands of years. And these swings, well, they could be so extreme that it made it really difficult for complex life to actually evolve and survive.
So the moon is like what? Like a cosmic shock absorber, basically?
Yeah.
Smoothing out Earth's ride and making it a much more hospitable place for, well, for us.
Pretty much. It makes you
So,
wonder how common, large moons like ours are, out there in the universe.
right. Yeah, I never thought of it that way. It makes you think, were all of these things about Earth, I mean, like its position in the habitable zone, its magnetic field, this large moon, were those just, incredibly lucky coincidences? Or are there other Earth-like planets out there that have, similar features and maybe they're harboring life too.
That's a big question, isn't it? And, while we're on the topic of big questions, we've been talking about all this evidence for past liquid water on Mars and even the possibility of, flowing water today. But what are the chances that we're actually going to find, living organisms on Mars, like right now?
Yeah, that's what I want to know. Like, are there little green men hiding somewhere?
Huh. Well, maybe not little green men, but there have been some pretty intriguing findings that, well, they kind of keep that possibility alive.
Okay, like what have scientists found that suggests there might actually be, I don't know, like microbes or something hiding out on Mars?
Well, one of the most compelling clues is the presence of methane in the Martian atmosphere. And, methane, it's a gas that can be produced by both biological and geological processes.
So finding methane on Mars doesn't automatically mean there's life there, right?
No, you're right. But the interesting thing is that the methane levels on Mars, they actually seem to fluctuate, seasonally. And that kind of hints at the possibility that that there might be some kind of biological activity going on.
I see what you're getting at. So if there are, like, let's say, microbes, living underground on Mars, they could be releasing methane as part of, like, their normal living processes. And then those fluctuations in methane, well, those could be connected to, like, changes in the Martian seasons.
Exactly. You got it. And hey, remember those dark streaks we talked about earlier? The ones that appear on Martian slopes and that have been confirmed as, evidence of that flowing liquid water.
Oh, yeah, yeah. Possible signs of water on Mars today? What about them?
Well, some scientists think that those recurring slope lineae, that's what they're called, they could actually be potential habitats for, maybe microbial life. Imagine like tiny organisms just thriving in these briny flows, shielded from all that harsh radiation on the surface.
Like little Martian oases.
Yeah, exactly.
Yeah.
And what about those massive Martian canyons? Those could hold some clues about, past life too.
Oh, right. Those canyons, like Valles Marineris, I think it's called.
That's the one. Those were most likely carved by, flowing water billions of years ago. And if life did exist on early Mars, those canyons, well, they would have been prime real estate.
So if we're ever going to find fossilized evidence of Martian life, those canyons are probably the place to start looking.
100%. And in fact, that's actually one of the main goals of the Perseverance rover, which landed in Jezero Crater back in 2021.
Oh, right. Perseverance. I remember when that landed. Jezero Crater, huh? Why did they choose that spot for the mission?
Well, scientists believe that Jezero Crater was once a lake, fed by a river delta, and it's the perfect place to look for signs of ancient life because, billions of years ago it would have been this rich watery environment.
Okay, so Perseverance is on the hunt for Martian fossils in a former lake bed. Cool. But what else is it doing? Like, what are some of the other scientific objectives for this mission?
Well, Perseverance is packed with all kinds of cutting-edge instruments. They're designed to study Martian geology, the climate, and of course, the potential for life. And one of the coolest things about it is this tool called
MOXIE. That sounds familiar. Remind me, what is that again?
So MOXIE stands for Mars Oxygen ISRU Experiment. It's a pretty revolutionary piece of technology. Basically, it's designed to extract oxygen directly from the Martian atmosphere.
Wow. Why is that important?
Think about it. If we ever want to send humans to Mars, we're going to need a way to produce oxygen, right there on the planet. Not only do we need to breathe, but it's also it's a critical component of rocket fuel.
Ah, okay. So MOT is like a test run for future human missions to Mars.
Exactly. It's a crucial step towards, making human exploration of Mars a reality.
It's incredible, isn't it? Like, we're already developing the technology to support human missions to Mars. And that brings us, one step closer to answering that big question. Are we alone in the universe?
It really is an amazing time to be, following all the Mars exploration stuff. Every new mission, every new discovery, it brings us closer to understanding the mysteries of this fascinating planet.
And who knows, maybe one day we'll finally have, absolute proof that life did in fact start on Mars.
Now, that would be a game changer, wouldn't it?
Yeah.
It would completely revolutionize our understanding of everything. Life, evolution, our place in the cosmos. It would be one of the most profound discoveries in human history.
Absolutely. This deep dive has been, it's been incredible. We've gone from, ancient Martian oceans to the possibility of, methane-producing microbes and even even the ethical considerations of searching for alien life. And I think the biggest takeaway for me is that, the more we learn about Mars, the more we realize how much we still don't know.
That's the beauty of science, isn't it? Every new discovery, well, it just opens up more questions. It's this constant journey of exploration and understanding.
And as we continue to, explore Mars and in the rest of space, we're bound to make even more incredible discoveries.
Oh, for sure.
Yeah.
Who knows what's waiting to be uncovered out there?
It's really amazing, isn't it? All this work being done to explore Mars. It feels like we're, right on the edge of this whole new era of discovery. But even with all the technology and everything, there's this one question that keeps coming back to me. What if we don't find any evidence of life on Mars? Like, what then?
That's a really good question. And honestly, it's one that scientists have been kind of wrestling with for a long, long time. Some researchers, they believe that if life ever did exist on Mars, it uh, probably went extinct billions of years ago,
Yes.
right? When the
Yeah.
planet lost its atmosphere and all that water. But others think that maybe, just maybe, some kind of, I don't know, microbial life
Yeah.
is still clinging on somehow, somewhere deep below the surface.
Oh, wow. So like a whole hidden biosphere down there, shielded from, all the harsh stuff going on up above.
Exactly. I mean, think about it. The Martian subsurface, it could provide protection from radiation, and who knows, there might even be, like little pockets of liquid water down there heated by geothermal activity. It's a pretty amazing thought.
It is. It really makes you wonder, what kind of life could survive in that kind of like super extreme environment. And if it is down there, I mean, how different would it be from life here on Earth?
It's really a question that just fires up the imagination.
Hmm.
If we were to find life on Mars and it actually started and evolved completely separately from life on Earth, well, that would change everything. Our whole understanding of biology, evolution, the whole thing. It would mean that life isn't just this fluke, this one-time thing, but rather, maybe it's this fundamental process that can happen anywhere in the universe, given the right conditions.
That's a huge thought. It means we're not alone,
Yeah.
out there in all that vastness. But it also makes me think about, some ethical stuff. Like, if we do find life on Mars, how do we make sure we don't mess it up? Like, how do we avoid contaminating it with, I don't know, with Earth microbes or something?
Right. Yeah. Planetary protection. That's a top priority for all these space missions,
Mm,
especially the ones that are looking for life. The spacecraft, they're super carefully sterilized before they launch to minimize the risk of taking Earth microbes to other planets.
mm.
And once a mission lands on Mars, there are these strict protocols in place to try to prevent contamination.
It's almost like a giant crime scene, right? Where we have to
Yeah.
be incredibly careful not to, I don't know, mess up the evidence.
Exactly. If we find evidence of Martian life, we need to be able to study it in its natural state, its original environment, without any interference from Earth.
Right, right. I get it. So,
Yeah.
so even if we don't actually find, life on Mars, I guess there's still a lot we can learn from just studying the planet itself, right? I mean, it's like a time capsule almost, holding clues to the early solar system.
Absolutely. I mean, Mars can help us understand, those processes that shaped our planet and its neighbor. It can teach us about that delicate balance, that makes life on Earth possible. And maybe, just maybe, it can teach us how to protect our own planet from future threats.
This deep dive has been, wow, it's been a lot. We've talked about ancient Martian oceans and methane producing microbes and even, the ethics of searching for alien life.
Mm.
But I think the biggest thing I'm taking away from all of this is just how much we still don't know about Mars, about everything, really.
And that's the amazing thing about science. Every new discovery it leads to more questions, more possibilities. It's a journey that never ends.
And as we continue exploring Mars and well, the entire universe, I mean, who knows what we'll find?
Who knows?
Yeah.
But one thing's for sure, the universe is full of mysteries, and I think that's what makes it so exciting.
Well, that brings us to the end of our Martian deep dive. But before we go, I want to leave you with one last thought. As we keep exploring the cosmos, and keep searching for answers to these really big questions, one thing is clear. The universe is full of mysteries just waiting to be solved. So keep looking up, keep asking questions, and never stop exploring.